Thanks for picking up in part 2 here. So let's take a look and prove the isosceles right triangle conjecture. So we are given a right triangle with side length L and hypotenuse length X. And we actually might want to make with leg side length L. By the Pythagorean theorem, X squared, which is our hypotenuse, equals L squared plus L squared. So this time, again, our A and B are the same value because it's an isosceles right triangle. Simplifying, we're left with X squared L squared. Taking the square root of both sides gives us X equals L square root of 2. Because again, if we took the square root of this side and the square root of this side, we can take out a factor of that, and then square root to the side. And that's what we wanted to show. So that tells us that the hypotenuse is equal to the length of that side multiplied by the square root of 2. Now, another type of triangle is a 30, 60, 90 right triangle. And this type of triangle is formed by taking an equilateral triangle and making the angle bisector. And this uses our isosceles vertex angle conjectures. So what happens is when we bisect angle C, okay, because it was 60 degrees for an equilateral triangle, now it ends up as 30 degrees. And then, because the angle bisector here is perpendicular to the base, it's also the median. So we end up with a right angle at point D. So why must the angles in triangle BCD or ACD be 30, 60, or 90? So the 30 degrees came from angle C being bisected. The 60 degrees came from the equilateral triangle. And the 90 degrees is because the angle bisector is perpendicular to the base. So that's going to be important to convince us again what are the relationships that we have, and we're looking at any 30, 60, 90 triangle. So now the second question is, how does BD compare to AB? So if we take a look, here's BD, and here's AB. Again, the angle bisector here is the median to the base. So BD is 1/2 of AB. So then how does BD, I'm going to look at this triangle, compare to BC? So remember our original triangle, here's BC. BC is congruent to AB, and so therefore BD is also equal to 1/2 of BC. Or to put it another way, so the next question asks us, since this generic 30, 60, 90 right triangle, how does the length of the hypotenuse always compare to the length of the shorter leg? So BD was our short leg. BC was our hypotenuse. So that means that the hypotenuse is always twice the length of the shorter leg. I want to back up a second real quick and just go through and make sure we understand where the shorter leg is coming from. So remember when we looked at the lengths of the sides of a triangle compared to the angles that were across, we decided that the longer side was across from the largest angle and the shorter side was across from the shortest angle, or the smallest angle. So the side across from the 30-degree angle is going to be the smallest side. The side across from the 90-degree angle is to be the largest side, and then the side across from the 60-degree angle is going to be the longer of the two legs, or the side that's in the middle length. So that's something to keep in mind as we work through some of these problems. So now go ahead and fill in the chart. We've already figured out that for each of the shorter legs, if we're given the length of each of the shorter legs, we just double that to find the length of the hypotenuse. This would be a 6, sorry about that. Now, I want you to go ahead, I want you to pause the video, use your Pythagorean theorem, and find the length of the longer leg using now your shorter leg and your hypotenuse. And then come back and take a peek. So you should have found that when you use the Pythagorean theorem, that the length of the longer leg was always a multiple of the shorter leg, the length of the shorter leg, and the square root of 3. So that brings us to our 30, 60, 90 triangle conjecture. In a 30, 60, 90 degree triangle, if the shorter leg has length A, then the longer leg has length A times the square root of 3, and the hypotenuse has length 2A. So again, we can use this given information in all sorts of different situations. So let's take a peek at the first problem we have. So we know that if this is the 60-degree angle, this is the longer of the two legs. So this leg, 12 square roots of 3, is square root of 3 times the length of the shorter leg, which is A, which means the shorter leg is length 12. And then the hypotenuse, which is B, is double the length of the shorter leg, and so therefore it would be 24. This other one, a little bit more complicated. So we have a a trapezoid, and we are going to drop down two perpendiculars here. So at this time, maybe you want to pause the video for a second and see if you can come up with what we're going to do. And then take a